Construct in your mind a perfect cube of reinforced lead walls 3 feet thick. Weld the seams until they are seamless. Connect a pump of infinite capacity and begin to extract the air. Watch the pressure gauge fall. 1 atmosphere, 1/1000th of an atmosphere, 1/10000000th. Continue until the chamber is ostensibly void of all matter. No oxygen, no nitrogen, no stray dust motes dancing in a beam of light. You are left with what classical intuition calls a vacuum, a volume of absolute absence. You are wrong. You have merely cleared the stage of the actors. You have not removed the stage itself, nor the curtains, nor the air conditioning that hums beneath the floorboards of reality. To understand why nothing is an impossibility, we must descend from the macroscopic world of steel boxes into the subatomic architecture of space itself. If we magnify that empty cubic foot of space 10 trillion times, we do not find a smooth black nothingness. We find a violent, roiling ocean. We find the quantum foam. In the early 20th century, physics stripped us of the comfort of stillness. Werner Heisenberg demonstrated that nature prohibits absolute certainty. You cannot know a particle's position and momentum simultaneously with perfect precision. This is not a limitation of our measuring tools. It is a fundamental property of the universe. This uncertainty applies to energy and time as well. This means that for exceedingly short intervals of time, energy can fluctuate wildly. In your empty box, particle-antiparticle pairs are constantly snapping into existence and annihilating each other in a duration so short it defies human comprehension. Electrons and positrons materialize from the void, borrow energy from the future, clash, and vanish, returning the energy to the vacuum. This is not theoretical poetry. We have measured it. The Casimir effect provides the smoking gun. Take 2. Uncharged metal plates and place them nanometers apart in a vacuum. Classical physics suggests they should sit still, but they do not. They are pushed together. Why? Because the distance between them is so small that it excludes certain wavelengths of these virtual particles, creating a pressure differential. The seething quantum activity outside the plates is stronger than the activity between them. The nothingness is pushing the metal. The nothingness has weight. We must peel back another layer. We used to believe that fields, magnetic, gravitational, electric, were invisible grids overlaid upon a background of empty space. Modern quantum field theory corrects this error. The fields are not on the stage, the fields are the stage. The universe is filled with fields, fluid-like substances that permeate every point in the cosmos. What we perceive as a particle, a solid electron, is merely a localized vibration, a ripple in the electron field. When the ripple calms, the particle vanishes, but the field remains. It is like a silent guitar string. The sound is gone, but the tension in the string, the potential for sound, endures. You cannot remove the fields. To remove the fields would be to remove the laws of physics themselves. Therefore, even in the deepest, darkest void between galaxies, the grid of potentiality exists. There is no such thing as empty. There is only the ground state, the lowest possible energy level of a field, which is never zero. Let us expand our scope from the microscopic to the cosmic. Look at the darkness between the stars. We call it space. For centuries, we viewed space as a passive container, a static three-dimensional coordinate system where events took place. Albert Einstein shattered this glass box with general relativity. Space is not a container. It is a fabric. It is malleable. It stretches. It twists. It carries gravitational L waves, ripples in the very structure of geometry, moving at the speed of light. If space can ripple, it has substance. If it can expand, it has physical properties. In the late 1990s, we discovered that the expansion of the universe is accelerating. Galaxies are rushing away from one another faster and faster. Something is pushing them. We call it dark energy. It is an intrinsic property of space itself. It calculates to roughly 68% of the total energy in the observable universe. The more space you have, the more dark energy you have. It is the cost of having volume. This suggests that every cubic centimeter of the so-called void contains an inherent energy density. If you were to take a piston and expand the volume of your empty lead box, you would create more dark energy. You are generating energy from nothing, because the nothing was never nothing to begin with. It was a plenum. It was a fullness masquerading. Inging as a void. Consider the temperature of the void. Point a radio telescope at the darkest patch of sky, away from the sun, away from the Milky Way. You will not find silence. You will hear a static hiss. This is the cosmic microwave background radiation, the afterglow of the Big Bang, bathing every millimeter of the cosmos in photons. The temperature of deep space is 2.7 Kelvin. It is not absolute zero. Absolute zero is a theoretical asymptotic limit that thermodynamics forbids us from reaching. To reach absolute zero would require a system to have zero entropy, zero motion, zero information. The third law of thermodynamics stands as a sentinel at the gates of non-existence, barring entry. As long as there is temperature, there is radiation. As long as there is radiation, there is something. We must also confront the logical and semantic paradox of the concept itself. To define nothing is to enclose it. To say here is no thing is to assign it coordinates, a boundary, and a linguistic label. Mathematics struggles with this. Zero is a number. It is a value. It is a point on a line. It is not the absence of a concept. It is a concept of absence. An empty set in set theory is still a set. It is a container with no elements, but the container exists. The very act of observation collapses the possibility of nothingness. To observe a vacuum, you must shine light through it or measure it with a probe. The act of measurement introduces energy. The act of consciousness introduces a definer. If a universe contains no matter and no energy, but there is a consciousness to perceive it, it is not empty. It is inhabited by a mind. Let us go back to the beginning, before the Big Bang. Surely, you ask, there was nothing then. This is a trap of human grammar. We rely on the concept of before to organize causality, but time is a property of this universe, woven into the fabric of space-time. If the universe began at the Big Bang, then time began at the Big Bang. Asking what happened before the beginning is like asking what is north of the North Pole. There is no coordinate there. There is no then in which nothing could exist. The universe did not emerge from nothing. It emerged from a singularity, a point of infinite density and temperature. It expanded from everything compressed into the head of a pin, not from an empty room that suddenly filled with furniture. Even the death of the universe offers no sanctuary for nothingness. Trillions of years from now, when the last star burns out and the black holes evaporate via Hawking radiation, the universe will consist of a cold, thin soup of photons and leptons. It will be dark, it will be vast, but it will still be a thing. The quantum fields will still vibrate, the dark energy will still push, the fabric of space-time will still endure, stretched out, built over the skeleton of a dead cosmos.